Hello guys, welcome to my YouTube channel. My name is Kmeans. So I'm just going to do a brief introduction about me. Uh, I had my BSc in computer science from Ekiti State University, and I'm currently doing my master's degree at the University of Hertfordshire, where I major in data science. All right. So before then, I've had experiences in uh, data analysis. Uh, Yeah, where I use Power BI, Power Query, Excel. Yeah, and yeah. So the main reason I'm doing this video is to document my progress. I have not been doing video, and I feel like okay, I should start and document my progress and use it as my portfolio. Yeah. So I'll be putting these videos on my social media, not the videos exactly, the links on my social media. Then I'll be posting the videos on YouTube. Right. All right. So the major purpose of opening this uh, channel is because whatever I'm going to do now, for now, like I said, is going to be to document my progress. Yeah, so with that being said, that means is going to be within the scope of what I'm being taught in class, right? But it's just for now, right? Just for now, but uh, within the scope of what I'm being taught in class, just for now. So yeah. Also, we'll be performing um, data cleaning on different data. We'll be performing EDA, yeah, and visualizing data and getting insight from those data. What can we get from those data? And also we'll be writing a report on those data. Right. So that's just one of our assignments we're asked to do. I will be uploading some other videos about the assignments I've done in the past. So yeah, just look out, watch out for those videos. Yeah. All right. So the video I'm going to do today is fitting and clustering. Yeah. So it's the assignment is based on fitting and clustering. We have to take a data set from Kaggle or any data bank. We have to pick a data, clean it, visualize it, perform fitting and clustering on it, then write a report on it. What can you see? What can you say about this data? Yeah. All right. So I'm going to limit whatever I'm going to do now to the marking scheme, the marking guide of those of the lectures. And yeah, I would have loved to go extra, but it will just be within that, within the marking guide. So they don't get to subtract from my mark, but then yeah, so we just dive right into it. All right, so the data set I picked from Cargo is called energy production. Basically, what it does is it has a columns, it has about 10 columns here. So I'm just going to display the data here, energy production. All right, so it has yeah about 10 columns. Index column, date column, region, thermal general actual, thermal generation estimated. So it's like energy generated from different source, that is thermal, nuclear, hydro, from those three sources, and their total actual production, right? So it's going to be estimated value against the actual value. Then this energy are generated from different regions. So different regions at different day of the year. All right, so we're just going to start right now. So we're going to import, first thing is to import our library. I'm going to import matplotlib. spot, we import numpy, American Python, pandas, sorry, np, we import pandas, then I'm going to use Seaborn in my visualization, so import Seaborn as well, import Seaborn, nice, so nice. Alright, and also some of the libraries I'm going to use SciPy. From SciPy, optimize, we import the call fit, because since I'm going to be performing a call fit, okay, from, so I'm just going to import the libraries first, and I'm going to explain a little bit of what these libraries mean or what they do from sklearn. That cluster, this is for clustering. I'm going to import kmeans. Also from sklearn, we are going to preprocess, so from sklearn that's preprocessing, I'm going to import my method, the method I'm going to use for silhouettes. Oh, sorry, I mean I'm going to import my standard scalar, not silhouette. Yeah, the matrix is the silhouette, while the processing is the, we are going to normalize, so we are going to use a standard scalar. Standard scalar. Then from sklearn matrix into import silhouette score. And so this is basically what I'll be using for my for the assignments. Yeah, so since I'm performing fitting and clustering, then I'm going to do a categorical graph. I'm going to do a categorical graph. I'm going to do a statistical graph. I'm going to do a correlation graph too. Yeah. All right. So what's this sklearn? Sklearn means is a general machine learning library, right? It's also known as a scikit-learn. Yeah, the scikit-learn is like the library itself, while the sklearn is like an alias. Yeah. So yeah, what it does is it provides a lot of tools for machine learning and statistical modeling. When I'm talking about statistical modeling, I'm talking about classification, regression, clustering, dimensionality regression, right? Yeah, and talking about classification, which is very important. So that classification means it means we are either identifying or categorizing data based on patterns, right? Based on patterns. So that was what sklearn does. Preprocessing means we want to preprocess our data yet. So we import standard scalar because standard scalar is used to normalize. You can either use robust scalar or standard scalar. There are other things we can import, you can use, right? But I'm going to use standard scalar for this. Then kmeans is used for clustering. Why curve fit? Yeah, I've not explained this. So curve fit means so when you say fitting, what comes to your mind? When you are saying fitting, you're talking about in Python, it means process of finding mathematical functions that best describe a set of data points, right? And there are different types of fitting. There's linear fitting, there is non-linear fitting, a lot of fitting. There is polynomial fitting, and there are methods in which we fit. There are a lot of methods as well, but the one that we're using is curve fit, which is the scipy dot optimize. Yeah, that is curve fit. Or we can also use numpy polynomial fit. So we can either perform different type of fitting on them. We can do exponential fitting, logistics fitting, quadratic fitting, polynomial fit, yeah, and on like that. Yeah, so silhouette score means is a method in which you know the number of clusters we are going to use in our clustering. The silhouette score tell us number of uh, the number of clusters we are going to use. Another method is either we use silhouette score or we use able method. That's just what we the libraries. That's just the brief explanation of the libraries, right? So I'm just going to run that. So here I'm going to load my or read my data set. So I'll be using pandas to read my data set. Pandas is quite easy when you think about it compared to NumPy. Pandas is easy to read. I love pandas to read. So I'm going to load or read my data. Read the data. So I'm going to name it energy equals to pd dot read underscore csv because it's a csv file. Yeah. So the name of this data is what is energy underscore production dot it is dot csv. Yeah, we can see from here like this energy underscore production dot csv. So just to be sure we are on the right track, I'm just going to print the edge energy dot edge. I want 10 of those. Alright, so here we have it. We have the columns and the rows. So to check, so we have the dates column, the region column, timer column, and so on and so forth, and the total actual production column. Alright, so let's check the number of, you can check the shape or the length of our data set. So I'm just going to say check the length, right? Check the length of data. To check that, we just do length of data of energy, right? Okay, so right now we have about 4,945 rows of those data. So let's check the shape. The shape is going to give us the number of rows and column, right? It's going to be energy dot shape. Yeah, yeah. So there we go. We have 4,945 rows and 10 columns. Alright, so the next thing we are going to do is check the information. What can we say about this data? What are we looking at? So to check the information, we do check the information is taken. We'll use energy.info. Alright. So what this data is telling me is that I have 10 rows in 10 columns, and my index is integer. My date column is in object, which should not be in object. My region object, fine. My others are in floats, right? And yeah, we have about, these are the total number of rows, and here we can see a difference about 1,900 plus data are missing from here. Alright, so later on we are going to decide what we are going to do with those missing values, right? We're going to decide what we are going to do with it. Alright. So the next thing to do is first I like to convert this date in objects. We have to convert to a date time data type, right? So in order to do that, we are going to do convert date to from string, using string, right? Convert date from string to a date time format. Going to convert to a date time format. Alright, to do that, we are going to just say energy. Then what are we converting? The date, right? The date to what? I'm going to say equals to pd dot to date time. Yeah, this time energy. Okay, date. Yeah, so to be in formats, the format to be in, notice that okay, just a moment. This is yeah. So yeah, notice that yeah, the format of the date is starting from a day, month, and the year. There are some data set that is going to start with the year, month, and day, or the year, day, and month. So we are going to follow this exact same pattern to write out for the format. This is going to be the day first, which is D for day, and in to be for year, a month, and a month, and then year, which is Y. Alright, so to check that, we are going to do, you can check the conversion. I love to do mine in different cells, right? So we are going to check the conversion. Let's check the conversion if it works. Oh, we have now error. So to check the conversion, we just do the date, the energy date dot info, right? To get the info of that. There you go. Alright, cool. So here we go. So we've changed the data type from object to date time format. Alright, so the next thing I'm going to do here is to check for, are there any missing values. Of course there are missing values, but to check that, we can do check for missing values. Check for missing values. So there are two ways I know to check for missing values. You can do You can use is NA or you can use is null. So I'm going to use NA. Is NA dot next dot is NA. Alright, so we can decide to leave it like this, but this will output a series of Boolean output. It's going to give us a Boolean output, that true or false. It is true when there is a missing value, there is a non-value, then it is false when there is no non-value or there is no missing value. Alright, so we are just going to check that in a moment. Alright, so here we go. So you can see it's giving us a Boolean output false, 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 true. That means there's a missing value right there. But this is going to stress us. So the best thing is just to add dot sum. We're going to sum it. Dot sum will just give us a concise explanation of what is going on. In the data set, maybe there is no value or not. So when we add dot sum, yeah. Alright, so it says there is no missing value. Yeah, there is no missing value. And the only place we have missing values are in the nuclear generation actual and the nuclear generation estimated. And we have about 1978 missing values. Right, so what do we want to do with these our missing values? Mind you, we need to get rid of these missing values or just find solutions to them. Right. So what we can do is either use the mean for them. We can fill in the missing values by using the mean, or we can drop the rows that has the missing values or columns that has the missing values. Right. All right. So yeah, I'm just going to should I use mean? I'm going to drop. I'm going to drop. So I will dropping the missing values. Or we say dropping the rows with the non-values. Dropping the rows. With the non-values. So to do that, we are going to use drop NA because they are non-values, right? So drop NA. Energy dot drop NA. Since they are rows, the difference between rows and column. Alright, before that, I'm just going to finish what I'm doing. So axis is 0 and enclave is true. So what this does is axis minus 0. So axis is 0 when it is the rows and it is 1 when it is the column. Alright, so if you are dropping a remote value in the column, we are going to change the axis to 1. And if you are dropping the null values at the rows, we are going to use 0 as our axis. Then in place true means I want you to replace this new data with the old data. I just want you to update the data, change it in place true. So we can either use in place equals to true or dot copy, right? But when we are using dot copy, we just have to change the variable name again, like energy equals to energy dot drop any x0 dot copy. Yeah. Alright, so we are going to drop that and run it. So how do we know if we have dropped that? To check the length of data drop in the null values. We use length. We can use length, or we can use shape, length of energy. Alright, so notice that here we have about 4,000. Yeah, we have about 4,945 rows, but here we now have 2,967 rows after dropping the null values. That means about 1,978 are the um, are rows. There are 1,978 rows with missing values. Alright. Okay, so the next thing I'm going to check for is to check duplicates. So what I'm basically doing now is performing EDA, explanatory data analysis, and data cleaning. Right? Yeah, so I'm going to check my duplicates and remove duplicates. Remove duplicates. To remove duplicates, I'm going to use energy dot drop what colon sorry drop duplicate and yeah, drop duplicates. So yeah, I'm going to just use dot copy. So this is what I'm talking about. You can either use this dot copy or use in place equals to true. So I'm going to use dot copy. So it's going to update the new file. Right. So let's see. Let's check our data. You see how far into our data that's edge. So I'm just going to print like 10 or I'm going to make 10. Alright, so data is so I have necessary column here. So I'm going to drop that. Let's drop the unnecessary column. Drop necessary column. Drop the unnecessary column. Okay, to drop the unnecessary column, I'm going to use energy dot drop. Since you are dropping column, drop column equals to yeah the index, the name of the column which is index, which at what axis? At axis 1, because at axis 1 because it's a column, right? If it's a row we are dropping, we use axis 0, axis 1 now. Then in place equals to true. Alright, so let's check. Is it gone? Oh, I think there's a name error. Yeah, name error. Energy. Good. Okay, so we drop the index column here. drop that. So right now we have a clean data. Alright, so I'm going to start the. So we are told to visualize one of these categorical, we are told to visualize a categorical plot, right? So categorical plot can be either bar charts, pie charts, histogram, or any of these charts that categorizes data, right? And so I'm going to use depth plot categorical categorical distribution categorical distribution. Um, what my lecturer wants to see is use a doc string. So you have to use a doc string. Create what this does is create a bar chart. I'm going to a bar chart to do what? To show it's going to show the um, distribution of the okay, so I'm going to create for the total actual production, right? I'm going to see how a certain region, how the region produces uh, the production of the total production of energy from those regions, from these regions, right? So in this case, I'm going to use group by in this case, but let's take it, show the total actual production, total actual production by region, by region. Closure dot string. So I'm going to use group by. So what I'm going to do is group data by region and calculate data actual production, data actual production. So I'm going to call it region data. Region data is going to give me energy dot. I'm going to use group by, right? Group by region. I'm going to group it by region. 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 Then what am I calculating? The total total actual production. Total actual production. Dot sum. I'm going to sum it. Since I just need the sum of the total energy produced, right? So I'm going to plot the bar chart right now. So plot bar chart. So plot dot figure. Sorry, I like to talk when I'm writing code, so I understand more when I'm talking. Goes to fix size. I'm going to use 8 by 8. 8 by 8. Yeah. So to be regional region underscore total dot plots. What kind of plot do I want to have? I want to have the bar chart, right? Bar, nice bar. Okay, what do I want to do? I want to have bar, then add a color to it. Color it green because I love green. Color it green and the label it was total actual production by region. Then what else can I add? I can add my width. Let me have width equals to 0.8, 0.6, 0.6. Alright, so yeah, I'm going to do plt dot x label. I'm going to label the y-axis and x-axis label. This is my x-axis. My x-axis will be the region, right? Because I'm grouping by region, so it will be the region. Let's give it the font size. Font size of I'm going to use 14 for the font size and my y label as well. plt dot y label. That is the total actual production. Actual production. I'm going to give it the font size of 14 as well. Then I have my title. I have my plt title. I'm going to put that the total actual production by region. I'm going to give it a font size. It's 14 as well. I'm going to set my ticks and give it a font size of 12 and white ticks, which is white ticks. So since I have my label and my legend, so these are the things my lecturer want to see in our code. The labeling, the legends, am I using sticks, y label, all those stuffs. Legend. Well, I'm using legend. Let me locate it. Put the location in the best position and give it the font size as well. Font size will be, I'm going to use 12. Alright, so ordinarily when you're using a notebook, Jupyter notebook, Jupyter notebook knows that you want to, when you are done with your code, knows that you want to show your plots, right? But The lecturer wants to see this plt.show to show it. Then I'm going to return. So return. So I'm going to call my function here. Right, so we have an error as no attribute group of group by group by group by. Works now. Alright. Matchplot with sticks. Good. So I'm going to change the rotation of my sticks. It's at 90, so I'm going to change the location to 45. Rotation, not location. Rotation. Alright, so that looks better. So yeah, we have our categorical distribution and a bar chart, right? Right, so you can see a lot of things from this plot. Right there, we can see a lot of things. I can see that uh, the western region has more production than the other regions, right? So yeah, and it seems like the western region is producing double as southern region. Yeah, so why the northern region has more production than the southern region? Okay, so a lot of things a lot of insights can be gained from this plot. We can say why is this happening? Why is the western region producing a lot of uh, energy compared to the southern part, compared to the northern part? We can say a lot of things. We can say probably like there are a lot of power consuming companies in the western part. So they have to produce a lot of energy, right? Compared to the southern part. You can say a lot of things. That's just speculating, right? So we are done with this. And just purpose of this, I'm going to do a histogram. I'm going to do histogram just for the purpose of this. Def categorical plots, categorical distribution, histogram. Create your doc string as well. This does create histogram to show. I need to show the distribution, right? The distribution of so what I'm going to do is to show the distribution of total actual production. Why should I use into plots? Just plots to histogram. So here I'm going to use plot dot figure my fixed size. My fixed size is equals to, I'm going to use 8 as well. My fixed size is equals to 8,8. So I'm going to use a Seaborn to visualize this histogram. I'm going to use SNS dot list plot. After plotting, we're plotting the total, we're plotting imaging. In energy, we are plotting the total production. Yeah, so let's give it some colors. Let's add some sorts in there. Let's give it my beans, of course, my beans is 30. I'm going to use KDA, the kernel distribution. I'm going to use, which is always true, because I want to show the kernel distribution, right? True. I'm going to add color to it. Color, let me use purple. Purple. And I'm going to label it as well. Total energy. Production. So I'm going to display the plots. I'm going to use my labels, plot.x labels. Choose label size is x label. Yeah, that's the total. Production. The font size. Font size of 14. So because I'm doing an histogram, right? So it's going to be the frequency of the total energy production. So my y-axis will be the frequency. I'm going to give that the font size. Font size is use 14 as well. My x ticks and y ticks. Let me give the title first. Title will be distribution of total energy. Production. Yeah, so I can have my font size as well. Font size 14. mathematics, numbers with the font size, nothing code. So it as well. Change. Okay, let's see the best part. Give it a font size of 12. That's about sure. That's about sure. Into it. So I'm going to call my function. Right. Okay. Oh. So what I'll do is I'm going to bold the labels. I'm going to put my books here. Wait. Let's bold. Let's do that here as well. Right, so you can see this, the title and the x-axis, the x label and y label, they are both. Yeah. Just so it has meaning, I'm going to show the mean and the median on this plot, right? Before the plot. Show the mean and median. Median line, right? I'm going to use PLT, PHP line, PHP line. G, total action production, time for production dot mean. That's mean. I'm going to give it a line style. I'm going to leave it a color, so it looks different from distribution. And so I have my color. I'm going to use color blue. I'm going to have a line style. I'm going to label it. Label it as mean. And let me give it a line width. I'm going to give it a size. I'm going to make it that 3. It's 3 or 2. I'm going to use 2. I'm going to do the same for my median. So that's this one. G. I'm going to use K. K means black, right? That's black. And then star. About its median. That's the 2. Right. So here we have our median line and mean line here. The one is the mean line and the black is the median line. Alright, so from this histogram, a lot of things can be deduced, right? This is bimodal distribution. This is bimodal because of the 2 peaks here. This is bimodal distribution, right? And it is right skewed, right? Then it is close to symmetric and right skewed. Yeah, I'm just going to find that out for my report. I'm going to write the report though. So the next thing I'm going to do is relational graph. The question says find plot or categorical relational either line or scatter plot. Right, so we for the relational graph we're going to do scatter plot, right? So plot relational graph. Relational graph. This will create a scatter plot to show the relationship between. So I'm just going to pick, since it's a relational graph, it means it has to have 2 parameters, different label for your y-axis and your x-axis. When you are showing relationship, means that's 2, more than 2, more than 1, right? More than 1. Alright, so I'm going to show a relationship for, let me see. I'm just going to show for the timer generation actual and timer generation estimated. Matching matching, which is in MU, right? In MU as well. So I'm going to plot fitting. Check sense, we use the command. Plot the scatter plot, so I'm going to just plot the scatter. In energy, plot, okay, we want to plot, that is the timer. I'm going to plot this. It should be MV. Yeah. So my x-axis and my y-axis energy. Energy. This. Right, so I'm going to give it I'm going to push it up into alpha 0.7. I'm going to use a marker shape. I'm going to use a marker of I'm going to use a label. I'm going to label it as, they are points, right? So they are thermal points. So to use thermal points. Thermal points. Alright, so my label, my X label and Y label. Since this is my X label, I'm going to do this, but this is estimated, not actual. Generation actual, generation estimated. Estimated. going to give this a font size 14. The font size of 14 as well. Need to give it a title. Into since they are both tama, so it will be tama generation. Extra estimated and to do the font size. Font size of 14. And I'm going to use the weights. Yeah. That's the this is a page creating the page position and size. So I'm going to call my function. Yes, just so we see this very well, I'm going to break this from here. Yeah. Right, there's an error. We have a key error. Key error, command generation in MG. Right. Command generation in view. Which is correct. Command generation in MG. Oh, right. Yeah, there's a space there. Yeah, so command generation. Fine. Right, so there we go. So this is our scatter plot, right? So this scatter plot, we can see a lot of things as well. Uh, this is positively correlated data, and yeah, they are positively correlated. And here seems to be some outliers right there. They are highly correlated data. It is because they are in, I think, yeah, has more dense data points compared to this space, right? Yeah, so they are, these are definitely outliers, right? It says, okay, make a statistical graph, either heat map or box plot or volume plot or corner plot. So we have to pick to make just one statistical graph. So I'm going to do an heat map for my statistical graph. So it's just plot statistical heat map. Statistical heat map. Yeah, graph. Let's create heat map to display this. What heat map does is shows the correlation, right? It's going to show the correlation between the numerical columns of your data set. To display the correlation between all numerical columns. And so first we are going to calculate the correlation matrix. Yes, calculate the correlation matrix. This is where we use dots co to get the correlation between the data sets. So we're just going to call it correlation equals to the energy. Notice that we can do energy dot co or to spice things up, we can, since our data types are all floats, we can select the data types that we want floats, right? Floats, we all want the one in float. So we can tell it to energy dots, we can do a select dot select data types, which includes include 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 only the floats 64. So 64, yeah, the coefficient, right? Go back into work, right? Okay, so we'll go ahead to plot the correlation. Plot. plot the heat map, I'm going to use Seaborn as well. But before then, my PLT.figure. I'm going to use fixed size 8 by 8 or 10 by 10. Use 10 by 10. Use 10 by 10. SMS note heat map. Correlation. I'm going to give it, I'm going to annotate it, annotate, which is true. I'm going to annotate, yeah, true, true. Okay, what kind of C map am I going to use? Color map. So I'm going to use, there are different type of color map you can use. You can use a Viridis, there's Viridis, there's a cool one, there's Nippy Spectra. I love Nippy Spectra because it just has this taste of colors. So I'm going to use a Nippy Spectra. Nippy Spectra. What's that? Simple quotes. Yeah. So draw the line width, which is use 0.8. Use 0.8. 0.8. So I'm going to give the title. Yeah, to the title. It's known as what? The correlation. It's known as the correlation. It's more. Use a caps there. Smart matrix. I'm going to reboot it. To put that, and I'm just going to show it. Going to get show. Yeah. Then I'm going to call my function. Yeah. Error. Float. Float. Type error. Float. Right. One time error. More than one figure. Come for single artist in more than one figure. The one time error, right? Let's see. Fixed size. Let's figure. Right. Great. Okay. Oh, this is too big. I'm going to use it by 8. Yeah. We got to better now. And so Mm. You can see that it's highly correlated. Highly correlated. So in correlation, we always have the value should be, if it is correlated, it is highly correlated. We always have is equals to one. It's not always greater than one, right? Yeah. So if it is correlated, it is one. The strongly correlated is one. It is near or 0.96 is strongly correlated, right? And the least correlated 2 minus 0.14. Yeah, and that's between hydro generation estimated and nuclear generation estimated. So here as the least correlated data. Yeah, here's the least correlated data. And we have a strong correlation right here, 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 and these, these are actually the same. We can do a corner here. So it's just going to show us half of this. Alright, so this is the color map. 1.0 being the strongest, the most correlated, followed by 0.8, followed by 0.6, 0.4, 0.2, 0.0, 0.4. Yeah. Right. So the next thing is to do a fitting, polynomial fitting. I think I'll do. So I'm going to stop here for now and make sure you subscribe, click the like button, subscribe to my channel. Thank you.